Hi, this is Tim Weckberg. I'm the CTO for SCEDMD, here to talk about the Slurm 2505, 2511 releases and beyond. First, a quick recap of Slurm's development cycle. Major releases are made every 6 months. Slurm's version is made up of the 2 digits of the year, followed by the 2 digits of the month that it came out. Most recently, this is 2505 from May, 2511 from November, and then upcoming will be the 2605 release in next May. The major releases are supported for 18 months. Currently within that window are the 2511, 2505, and 24.11 releases. Maintenance releases, the third digit that's not shown here, come out roughly monthly. Generally only made for the most recent major release. There is a little bit of overlap right as the new major release comes out, but generally our focus shifts to the most recent. The exception of this being for any sort of security release that will be made simultaneously for all of the supported major releases. To start with today, we're going to talk about the 2505 release from May. First, and certainly predominant in the work that went into this, is this idea of network traffic encryption for Slurm, being able to encrypt all of Slurm's traffic. You may have seen in some prior releases that there was some starting points to this, but finally in 2505 we have this ability to encrypt all traffic. This is completely optional. It builds off of Amazon's S2N TLS library, which is itself wrapping OpenSSL or a different crypto suite. There's even a FIPS mode available within S2N TLS if that's desirable for your environment. Alongside this is this idea of a cert manager plugin. Cert Manager script especially is designed to just work with simple shell scripts to be able to assist with certificate management on the nodes, being able to generate, relay them back into Slurm's control plane, potentially even coordinate handing off those certificates to a CA for signature signing, and then distribution of the signed key back into the cluster. Adjacent to this is this idea of HTTPS support for the Slurm REST daemon. This is orthogonal to whether or not you encrypt Slurm's traffic. So you can run Slurm REST with HTTPS support enabled while still leaving the cluster communication unencrypted. You can encrypt all of the cluster communication while leaving Slurm REST just running with HTTP support, or you can turn it on throughout. But building again off that same underlying S2N TLS library. Also in this release is this idea of multiple network topologies. We have a new configuration file that helps support this by defining a number of what we call named network topologies. Each of those named topologies then can be applied to one or more partitions in the cluster. This gives you some flexibility if you want to set a default topology that your entire cluster should respect and schedule against, but then maybe provide an override, or you have a more specialized set of nodes in a different cluster. This gives you a lot more flexibility than the old model where a single topology had to be used throughout the entire system. This does, again, come with a new config file and a new config file format. Topology.yaml is used in this case instead of the older topology.conf format. You can see in this small example snippet here, there's 3 different topologies that have been named creatively as Topo1, Topo2, and Topo3. Topo1 is running the switch plugin, Topo2 is running the block plugin. Topology 3 is not really running a plugin at all. It introduced this idea of a quote-unquote flat topology as just a topology that has no actual topology to it, which can just be used as a default override to say don't respect and don't schedule against the network topology. So again, this gives you a lot of flexibility in how the cluster is built out and modeled, especially if you're sort of mixing and matching different interconnects within the system, or sort of aggregating different hardware pools together into one Slurm cluster. Alongside this is the idea of dynamic network topology. Especially for cloud and dynamic nodes, you previously had to define their place within the topology statically through topology.conf. Instead, this new slurmd option allows that node's place within one or more of the topologies to be enumerated. generally by just specifying the most immediate switch. There is some limited support for constructing a total topology ephemerally if you enumerate multiple switch layers all the way back to a predefined route. That's available as well. This dash dash conf topology is how you specify this when the slurmd starts up and then registers against the cluster. Further on in topology space, there's a few small changes for topology block. We started allowing gaps to naturally exist in the block topology. Previously, the topologies had to be sort of fully fleshed out, fully populated at each block layer. That led to some workarounds involving just providing fake nodes into the configuration, but that was always kind of a little unclean. This tidies this up and specifically lets you define blocks where you don't have as many nodes in the block as you otherwise would be expected to. Then, again, specific to topology block is this idea of a segment size for the job. We start capturing it in the accounting system. We make sure it's available in scontrol show job. And we added this Slurm job segment size environment variable into the batch step to make it available to the job itself. Another totally new subsystem that came in, and this will get expanded on considerably into the 2511 release when we talk about that in a little bit, is this idea of hierarchical resources. This is a new resource type to Slurm. It's similar to licenses and actually built off of some of the other internal license subsystems, but tracked against a hierarchy of nodes in the cluster. That hierarchy probably has a close resemblance to the network topology that you've defined in the system, but this is intentionally independent of that to give you some flexibility in how these are set up and managed. The configuration syntax, if you go look at this and start playing with this, obviously is closely related to that from the topology.yaml file, but is distinct. What this can get used for is allocating resources that are, say, part of the network and that have locality to specific sets of nodes. Specifically here, and in the 2505 release, there are just two modes that we introduce, mode 1 and mode 2, that do have some very specific limitations on how those resources are assigned and made available. Mode 1 is this idea of resources needing to be available within one of the layers that the nodes of the job are immediately a party to. This might be something like a network collective offload into the interconnect where a switch among the switches that are involved in this job needs to be able to provide it, but there's not necessarily a preference as to which switch. Mode 2 then goes a bit further and says that rather than just a resource, you need equivalent resources to be available from all of the layers. You can think of the layer as a switch that nodes from the job have been selected for. So maybe this is representing something about bandwidth, or maybe the collective offload support in your interconnect requires equivalent allocation across all of the participating switches. Mode 2 can be used to do that model. There is then, again, in the 2511 release, we'll talk about mode 3 coming in, which adds some much more interesting capabilities as well. Some other sort of smaller amendments here is for JobComp Kafka, there's this idea of logging start messages as well as completion. This is the same data roughly that we would send as part of JobComp, but now sent as job start as well. There's additional parameters, obviously, to enable this, specifically this enabled job start. And then for Kafka, you have the topic that you're going to send it over to. Job comp as the plugin is now not just completion, it is now completion and also start, specifically for Kafka. Some other small tweaks here for the PMIX library integration. We've enabled MPMD support. This is automatically translating heterogeneous step launch into the corresponding PMIX MPMD data structures to make that available there. We added support for an OR operator as part of a license request, giving a bit more flexibility in how licenses are set up and managed. If you had, say, two interchangeable pools of licenses and you just wanted the scheduler to be able to sort of hint to the application, to the job, which pool of licenses they should actually go and request the real license from, you can now specify the license request as license 1 or license 2, and the scheduler will give you license 1 or XR license 2. Some new task management capabilities came in. There's this new srun wait for children option. This allows the process that srun launches to fork off a bunch of different child processes. Usually, without this option, when that coordinating process, that first process that srun launches, exits, Slurm will automatically tear down and terminate any other processes that were spawned. If instead you're using that process really just to bootstrap a lot of loosely coupled components, but that you need those to all independently run to completion, this removes the reliance on that first process we launched to serve sort of as the controlling, almost a init style for the rest of them. So it can return and exit while all the children are still running to completion, and we won't tear the step down until they've all completed. This does require use of the cgroup v2 plugin. This is something where we're starting to push for some features and functionality that are only going to be available in cgroup v2 going forward. We did not want to try to re-implement in this in v1, especially that there's a number of race conditions and how this could work in v1 that we did not want to contemplate. Some small changes came in for Slingshot on HPE systems, specifically being able to work with higher core count processors and make sure that we can run over 252 tasks per node successfully. This does require updates to their libcxi library. We also added optional support for MTLS authentication to the Fabric Manager. That Fabric Manager is what sets up collective support on Slingshot fabrics. Some small tweaks to reservations, specifically getting the reservations into the REST API, so you can set up and create them there, and then capturing job reservation requests in the accounting data. This was a sort of surprising oversight that hadn't been enumerated yet. Then, and this is principally for the Slinky project, but can potentially be used by other external job orchestration systems. It can be used actually fairly powerfully for simulating and sort of building test frameworks around Slurm, is this idea of external jobs and external nodes. External jobs are special in that there's no batch script associated with them. They do not trigger prologue or epilogue scripts. They don't touch any of Slurm's resource management layer. They're really just a pure scheduling entity. You can think of them similarly to sort of an salloc, just without a controlling terminal. They're purely a resource request that is scheduled and requires some external process to be able to stop them eventually. Otherwise, that allocation will persist throughout the runtime until it hits the end time. It is automatically stopped. Then building and adjacent to this is this idea of an external node. External nodes are created through the REST API or can be created through the scontrol command. These are nodes that are pure scheduling entities. There's no slurmd process. Slurm's resource management layer does not exist for these. Something is externally driving and managing the state of this node. For instance, the Slinky bridge is specifically what was designed to consume this interface, to be able to purely manage and schedule against Kubernetes workloads that aren't going to run Slurm work. External nodes are only eligible to schedule external jobs because Slurm's resource management layer is not connected to them. We can't run a normal Slurm job on them. So these are complementary concepts of external job and external node, designed again really for the Slurm bridge part of the Slinky project to be able to come in and do pure scheduling disconnected from Slurm's resource management stack. With that, we're going to move on to the Slurm 25.11 release that just came out in November. The biggest, most disruptive part of this was this idea of expedited requeue. Um, we'll talk a little bit about what the real changes were, but the core concept here is to be able to jobs to requeue faster, expeditiously in particular. This is designed for sort of hero jobs running at a very large scale to be able to restart almost immediately in the event of hardware failures, um, rather than having and potentially, depending on your backfill and other system priority mechanisms, having a lot of nodes that were participating in a very large scale run potentially reassigned to other work. The idea here is to get that job rerunning and just pulling in one or two additional nodes that may have failed to replace them. The reason why this was fairly disruptive and required a lot of refactoring was that Slurm previously keyed all of its resource management layer off of the job ID. The job ID meant that launch credentials for steps could not distinguish between a requeued job, newly launched, and the original invocation of that job. That this ambiguity potentially would lead to some bad corner cases here that we needed to sidestep. The way that we managed this and made sure that no outstanding launch credentials were potentially outstanding for their original run was simply to stall for the credit expire window, which is default 120 seconds. By waiting for that credit expire window to elapse, this means that any launch credentials that the control plane could have issued are definitely no longer valid on the cluster, and it meant that then the job ID was presumed safe to relaunch and to re-kick the whole resource management layer. This 120-second default is obviously very unfriendly to these large-scale runs. That's potentially a lot of wasted system resources, or it's a window for other short duration work to sneak in and get backfilled in. Um, and we wanted to move past this. But moving past this required pivoting all of the underlying resource management layer from keying everything off of this job ID, which is the same on a requeued launch, to this other identifier that we'd recently introduced called the SLUID. That SLUID is changed and reset on each requeue, and that's what lets the resource management layer kick and relaunch this safely immediately rather than having to wait. The gotcha is that conversion at the resource management layer to keying off of the SLUID required changes basically to almost every RPC within Slurm, and represents a considerable amount of churn going into the 2511 release. And that's really, again, all of that is not meant to be really directly visible. It's just enabling this idea, again, of expedited requeue. So for expedited requeue jobs, if the job failed, that expedited requeue of the job is treated as having infinite priority. It does not sit there in the queue again at its prior priority level. It instead works at a layer completely removed from the normal job priorities. This does require explicitly enabling it first for the job with this new --requeue equals expedite option, as well as for the cluster administrators to have enabled this globally with Slurm control D parameters enable expedited requeue. This expedited requeue mode then is triggered either by failure of one of the nodes associated with the job, or by the batch script for the job returning a non-zero exit code, and then one or more of the epilogues associated with the job also returning non-zero and taking the node offline. The idea here is for the application to say, I did not complete successfully, and then defer to the epilogue as a way to catch potentially unhealthy hardware. So if the batch job returns a failure, but all the epilogues complete successfully, we're assuming that it's an application failure. If the batch job returns a failure and one or more of the epilogues fail, though, we're treating that as a lurking hardware failure that wasn't caught during the runtime of the application, but that does mean that we want to requeue and relaunch this automatically. and then kick off this expediter requeue behavior on the cluster. One sort of long-standing request and something that had been solved in a lot of different ways in the community, and then also by SkedMD for the Slurm exporter part of the Slinky project, was providing open metrics, aka Prometheus support, directly for Slurm. We had been shipping what we called the Slurm exporter, part of the Slinky project. The Slurm exporter had to go request data from the Slurm control plane through the Slurm REST API to then translate it again. Instead, we now have native support for exporting open metrics directly out of the controller. This is available also on the same port as the Slurm controller port, so that you don't need to look at changing firewall rules. This also serves as a nice health check that the cluster is responding. There aren't any firewall or other network complications there. So we recycled that same Slurm controller port, which can now talk HTTP to be able to do Prometheus. This is on by default. There is a way to disable it if you don't want it. Communication parameter disable HTTP is how you can turn this off. It's all the same data that you could access through the normal client commands, but again, just wrapped up into open metrics, aka Prometheus format. We do expect to potentially keep amending and modifying what's available. This does not yet support any sort of HTTP authentication. It's just available. That's something we will probably be looking at into a future release. The Job Container TempFS plugin, that's been around for a long time, we always knew this was sort of awkwardly named. Containers within the HPC community means something very different than what this was doing. Job Container TempFS really had turned into a very flexible Linux file system namespace plugin. And then we've been working to add support for other Linux namespaces as well. As part of this, we decided to rename the plugin interface from Job Container to Namespace. The existing Job Container TempFS plugin is still supported, still uses jobcontainer.conf for its configuration file, and has otherwise been renamed to Namespace TempFS. But then we've added a Namespace Linux plugin alongside that, which has support for managing PID and user namespaces as well as file system, and does come along with a new namespace.yaml configuration file with additional options, additional features. If you're using Job Container TempFS, you don't need to do anything. That's still working. Longer term, we will likely be deprecating Job Container TempFS as the Namespace Linux plugin does technically completely supersede it, just with the caveat that the config file format changed as part of that. We added this idea or changed a bit of the access controls. The reservations were usually keyed off of specific users, specific accounts, but we've added allow QoS and allow partition as additional controls, especially designed to work alongside magnetic reservations and actually make the magnetic reservations slightly less magnetic than they would have been otherwise. Just open some additional flexibility to how those magnetic reservations are being defined and used within the cluster. We added this idea of retroactively changing accounting data through the S-Account Manager tool. This was specifically intended for energy, but I believe you can change the alloc-tres values throughout as needed here. The idea here was to be able to integrate with systems where energy data is being tracked and managed by something external to Slurm, and that Slurm's built-in plugins aren't directly able to interface to. Instead, this gives them a way to that stack to retroactively update Slurm's accounting records, so the correct data can be attached there and persisted alongside Slurm's accounting view. Just that it has to be retroactively changed, and that there was not yet support for that in prior releases. Some other smaller S-Account Manager changes here. This idea of plus equals and minus equals syntax on group tres mins. If you're using group tres mins as sort of a bank account type model, being able to say you want to add another 10 billing units into there without having to do the math yourself by first querying what the current limit is, doing the math, sending the updated limit. Instead, let the Slurm database just do the math for you with plus equal minus equal support. I mentioned previously that hierarchical resources were going to get expanded. So the 2511 release is where we introduce this concept of mode 3. Mode 3, the resource usage is summed into all layers of the hierarchy. So rather than the usage either being equivalent or just used out of one of the layers, here the usage is aggregated as you go further and further up the hierarchy. This is specifically intended to do sort of power capping, being able to define layers that correspond to your rack, your aisle, your data center, and say that at this layer, that this is the amount of headroom we have, that this is the amount of consumable resource we have there, and then let Slurm factor that in as it goes and schedules all the workloads and make sure that we're not oversubscribing the power demand. There's a lot of other syntactic niceties that sort of came in to help support this model. The idea of this base usage that can be set on each layer that's just automatically subtracted from the resources available on that layer rather than having to derive it yourself, pull it out of the configuration file. We just let you say, hey, well, here's the total envelope, but I know this much is already being used. Longer term, this will likely let us do some dynamic updates to these as well. Right now, this configuration is somewhat fixed, but we have an eye to expanding this again in the future. There's also this idea of defining things that aren't nodes that also have additional base usage. So if you want to sort of accurately catalog, hey, this rack has this management switch that we know is using this much. We have the PDUs using this, fans using this. If you want to sort of separate and catalog those as sort of an easier way to revisit the configuration in the future, rather than trying to reverse engineer how that base load had been subtracted originally. This just gives you some additional flexibility, and it's all stuff that Slurm can just calculate up front. We also have this idea of allowing variables that map arbitrary names to defined resource counts. So if you want to say that a power use of or a resource of max P actually represents 1,000 watts of demand, that this gives your users a way to sort of not have to worry about the specific numerical representation, especially if you're running multiple clusters where different power modes may actually map to different underlying demands. That variable gives you a nice layer of indirection there, letting your users move the scripts between different environments a lot more seamlessly without having to adjust the actual resource counts on each of them. I didn't include it here, but the Slurm documentation site has an example of what this resources.yaml file looks like with these different configs built in. We did more topology work as usual coming into 2511. Specifically, a lot of things related to how segments behave. This complementary set of spread segments and consolidate segments options came in. One of them forces the block scheduler to intentionally move the segments between different blocks rather than trying to opportunistically fit them all into a higher level block. Consolidate segment instead explicitly demands that the segments are grouped within the minimum number of higher level blocks that it can to further limit system fragmentation and hopefully group them on a higher speed, higher kind of interoperability part of the interconnect. To be clear, the default topology block behavior lives in between these two ends of the spectrum where it's usually trying to consolidate the segments together, but it's not forced to do that consolidation. These options just give you some greater control over these behaviors. We also came in and added support for node list and exclude options as part of the job allocation. If there's reasons, especially for test development or to work around hardware problems, these are quite useful to give users a little bit of direct control over the scheduling behavior. They weren't completely supported with topology block, though, due to some architectural concerns. but we found ways to add limited support to make them work in most situations that your users would want. Adjacent to this were some updates to NVIDIA IMEX. NVIDIA IMEX is used usually on systems that are running under topology block to allocate distinct IMEX channels. This new network option, unique channel per segment, comes in to say that if you're using segment and you want each of those segments to be isolated from one another and assigned a different IMEX channel, Slurm will then do this setup automatically for you. Alongside this, some minor internal changes where we're doing the setup of the IMEX channel on batch and interactive steps as well. They were not configured on these previously. They were only set up on multi-node steps before. But if you're doing something in the batch or the interactive step to interact with a different workload that is using the IMEX channels, it's quite convenient to have that set up ahead of time for you. Makes debugging a little easier. Some minor tweaks came in for configless. We added support for sending the task prologue and task epilogue. We previously let you send prologue and epilogue. This is just a minor tweak to let those come in as well. Another sort of bigger internal piece that's not directly visible, but we do believe can significantly improve system resilience is this idea of asynchronous responses to RPCs from the Slurm controller. This is another capability in the Con Manager subsystem that we've been pivoting all of Slurm's communication into. This option is intended to improve the concurrency. It does improve the RPC throughput in our testing. Rather than individual threads within the Slurm controller blocked waiting for a response to make it all the way to the client command, the response is sent, and the Linux kernel worries about getting that shoved over the wire. The connection is still monitored by the Con Manager subsystem, so if there is a communication issue, we will catch that and then do any appropriate cleanup. But this unblocks the individual communication worker threads to return to the worker pool and start processing other RPC traffic much more immediately. This is the culmination of years of work into refactoring a lot of the RPC subsystems. We'll note that this is not on by default yet in 25.11, but we do expect to change that into the future. This is all a large part of sort of modernizing Slurm's communication structures and abilities to add a lot of resiliency and improve concurrency, particularly within the Slurm controller. Where we've usually seen some bottlenecks emerge under higher throughput, higher RPC monitoring load type environments. So that's it for the 25.11 release. Just a few notes on things that we've got upcoming and future releases. First, we have this idea of mini batch, where we're going to extend Step Manager to allow job steps to queue, work without needing to keep a controlling srun process around indefinitely. Step launches are tied one-to-one currently to an srun process living somewhere. Versus we can see a lot of use cases where you may want to run potentially tens of thousands, hundreds of thousands of small little fragments of an overall workload, but where you can't currently do that with step management because you can't keep that many srun processes around in the system successfully. This is not the final syntax. This is just a potential example of how this might behave of something like srun-batch. And this would just submit a step into the step management layer. The step management layer would then take charge of getting it placed and running on a particular node. And the I/O would behave much more like what the batch job I/O does and spool directly to a file, because we wouldn't have that srun command to pipe the I/O back to. I mentioned earlier that the Sluid is what we have pivoted to the resource management layer within Slurm keying off of. But it's not directly exposed in all of the client commands yet. There's bits and pieces where you can start seeing this. It is this 64-bit identifier for each job, especially it's each job run. It does change if a job has been requeued. It's an identifier that also then interacts and integrates into the database. It replaces something that used to be called the DB index value. But this is also available throughout. It's not tied to that DB index value, and it's generated directly by the Slurm controller. It's not something that is retrieved later on from the Slurm database. Again, a key part of this is it will change on each requeue. Job IDs don't. Historically, the sort of primary key for a job has always been the job ID and the start time. If you're building external integration scripts, that is something just to be aware of, that you can't distinguish that way, just solely on the job IDs. But instead, the SLUID you can, and you can treat it as a unique identifier for each run. There's an example of just one SLUID on the system. They have a lead S, and then there's 13 base 32 characters that follow. Base 32 just omits I, L, O, and U for their potential confusion. You can start seeing this S account format SLUID. You can see those back in the 2411 release. S control -- details show job can start showing them in 2511, and we're expecting to start exposing this and making these identifiers available throughout all of the commands, throughout all of the APIs into future releases. Just to give a heads up on some expected removals, we do expect to completely replace all of the proprietary GPU plugins within Slurm with ones that are directly built on DevFS and sysfs interfaces instead. We had started this with the GPU NVIDIA plugin. We eventually expect to retire the GPU NVML plugin. We are still working with NVIDIA to expose device-to-device links and usage data for that, which are the two gaps between those plugins today. We are expecting to remove the existing GPU RSMI plugin and do want to replace that with a GPU AMD plugin in the future. Slurm control deparameters enable RPC queue option is also now considered deprecated and may even be removed as soon as the 2605 release. This was an approach, again, an experimental approach that was never documented to adding a bit of resiliency and trying to mitigate some of the impacts of broader RPC storms to the Slurm controller. But our internal benchmarks that we used to keep an eye on system performance indicated that the option's actually detrimental starting in the 2505 release due to improvements that we made in the Con Manager subsystems. So again, we are expecting to just remove this. We have also then been talking a lot about potentially offering binary packages in the future, particularly RPMs, Debian maybe as well. This is why there was a survey question asking about this at the user group, especially because we realized that the Slinky project itself is already supporting binary container images, and the packaging for those is sort of held up on this idea that we first have to actually go in and generate container images off of building Slurm itself. If we can pull in binary packages for them, that kind of helps everyone. Just a few quick glances at some survey results from a survey we put out ahead of the Slurm user or Slurm community Birds of a Feather session at SC. One of them that I just thought was funny is an early version of this asked for the output from S-control show config on your cluster, and one site responded with output indicating that their primary controller wasn't online at that point in time, which I just thought was interesting. We do try to keep an eye on sort of evolution between different major Slurm releases and how quickly people are adopting those. It does seem like a lot of folks were still back on the 2411 release last month. People starting to shift onto the 2505 release. A couple brave souls already indicated that 1 week into the 2511 release being public that they'd already swapped in. And then we're still trying to get a better handle on kind of how to best address older unsupported and how to structure a lot of stuff there. One thing we've been keeping an eye on, and I'm quite happy to see an improvement in, and this is last year's slide from the survey, asking about sort of the evolution beyond RHEL 7. Last year at SC24, about the half of the respondents were still running it somewhere in their environment, but I'm delighted to say that is mostly resolved by now. There's just a handful of folks that are still stuck there for some reason. Um, Slurm is still built and tested against RHEL 7 internally within SCEDMD's test systems. Just longer term, there's especially a lot of features and capabilities that don't work there. And we would like to be able to say that that's completely out of support and stop worrying about a lot of the quirks there. Mostly there's a lot of eccentricities to the C compilers and the C standard that it supports that we'd like to move beyond. We had a few questions just sort of on general environmental things, just kind of keeping an eye on system throughput. Just quite interesting that quite a lot of the respondents have fairly modest numbers of jobs going through the system. So presumably longer duration, larger jobs versus a small group of folks in a more high throughput end of the spectrum. And then missing off this chart here, nobody actually responded on to the greater than 1 million jobs a day part of the benchmark. Driving again this potential idea of binary packaging was sort of surveying how are people installing Slurm today. Unfortunately, the way the chart broke this up makes it kind of hard to see some of the other options. Almost always involve building RPMs as part of this response, but overwhelmingly RPMs are the main install component. We're also curious just about OpenPMX adoption. Seems like a lot of folks are still potentially on much older releases that the OpenPMX projects have said that they're not supporting. That there may be some stuff that we look at amending or addressing there in the future. One thing we're interested in, this feeds into some potentially future changes around system architecture, would be the idea of making the extern step in Slurm always present. The extern step in Slurm is prolog flag contain is what enables that. Prolog flag X11 automatically turns that one on. Prolog flag alloc doesn't set it up on its own, but it's very closely related in what potential latency trade-offs on an individual application would come in from the system. So I'm actually still quite surprised to see that almost half the respondents say that they aren't running with this mode of operation, and we're internally trying to figure out what that might mean to some future plans that we have in that space. And with that's the end of the presentation we've got. Thanks to everyone that's been a part of getting these releases out. Thanks to the broader community for all the support and feedback over the years. We look forward to 2605 and the future releases coming out. So with that, thank you.